For ages, scientists have been wondering and arguing about how old the universe is. What seemed like a simple question turned out to be super tricky. And get this, even now, people are still debating it because there's always some fresh study messing with what we thought we knew about the universe's age and all those galaxies out there. Just last week, some crazy new research dropped, using data from the James Webb Space Telescope. It's shaking things up because it suggests the universe might be twice as old as we thought, like maybe 26.7 billion years instead of the usual 13.8 billion. If that's true, it could totally flip our current understanding of the universe and maybe solve some of those head-scratching mysteries about the first galaxies. But is that really possible? Let's check it out and see. One of the coolest facts we figured out about the universe is its age, 13.8 billion years. But now, a bunch of new research is making us rethink that number. If we go back in time, we see that the early universe was way different than what's floating around now. The stars and galaxies we see now came from younger stars merging together because of gravity. Way back at the beginning, there weren't any stars or galaxies at all. If we keep going back, we hit the Big Bang, which is basically mile zero for the universe as we know it. Right now, astronomers and astrophysicists who study the universe's beginnings say they've estimated its age with an error margin of less than 1%. Pretty cool, huh? So, how do they figure out these numbers? Well, there are two main ways, and both point to that 13.8 billion year figure. The first way is tracing the universe's history. It all started back in the 1920s when someone figured out the universe is expanding. Here's the deal, if you get how a system works and changes over time, you can guess what it was like in the past or what it will be like in the future. In space stuff, the rules for how the universe expands come from solving Einstein's theory of general relativity. Basically, the universe is filled with stuff spread out evenly in all directions. This gives us the Friedmann equations, which tell us how the universe has to expand or contract. Back in the day, scientists joked that studying the universe was all about finding two numbers that told you everything you needed to know: the Hubble constant, which measures how fast the universe is expanding right now, and the deceleration parameter, which measures how much the expansion is changing. Turns out, the universe isn't slowing down like everyone thought, it's speeding up. If we knew exactly how fast the universe is expanding, we'd know a lot more about what's in it: regular stuff, dark matter, radiation, and dark energy. And we could trace things back to the Big Bang when everything was super hot, dense, and crammed into a tiny space. How long it takes to get back to that point tells us the universe's age. But here's where it gets interesting. A study from July 7th is messing with those old estimates, saying they might be way off. This new study is tackling the problem of the first galaxies, which has been bugging scientists for ages. The study says that some galaxies that we thought formed right after the Big Bang might be way older than we thought. The James Webb Space Telescope showed that some galaxies, like this one called Methuselah, are supermassive and mature. You would assume it must have taken them billions of years to get that way. That's pretty weird, considering these galaxies were supposed to have formed only a few 100 million years after the Big Bang. A professor from the University of Ottawa thinks he has an answer. He says maybe the universe is way older than what we thought. His study has a new idea that stretches out the timeline for when galaxies can form. It suggests that the universe could be as old as 26.7 billion years. This new idea uses something called Fritz Zwicky's tired light theory. This theory says that light from far-off galaxies loses energy as it travels across space, which makes it look redder. That's different from the usual idea, which says that the red shift happens because galaxies are moving away from us as the universe expands. The tired light theory has been a hot topic, because people aren't sure if light could lose energy like that without also getting dimmer. Plus, Zwicky's theory didn't fit with the cosmic microwave background radiation, which is energy left over from the Big Bang. But now, someone suggested a way to make the tired light theory work with the expanding universe model. The idea is that the red shift is a mix of both things, the universe expanding and light losing energy as it travels. This also brings back an old idea from physicist Paul Dirac about blocking constants. These constants control how particles interact, and the theory says they might have changed over time. By thinking about how these constants might have changed, the new model stretches out the timeline for those early galaxies. Instead of forming just a few 100 million years after the Big Bang, these galaxies could have formed over several billion years, which would explain why they're so big and heavy. This idea also messes with the cosmological constant, which is supposed to be responsible for dark energy and the universe's speeding up expansion. Instead, the model suggests a tweaked version of the constant that takes into account how those blocking constants might have changed over time. This could explain why galaxies in the early universe were so small and give us a better idea of how the universe changed over time. What do you think? Have we been wrong all along? This could totally change how we think about the early universe. If it's true, it would rewrite everything from how galaxies form to the structure of space itself. It would also challenge what we've assumed for decades about when things happened in the universe. Scientists have always thought that the first galaxies formed pretty soon after the Big Bang, but the new evidence is making us rethink that. If galaxies like Methuselah formed way earlier, maybe we need to rethink the Big Bang itself. Could the universe be older than we thought? And if it is, how would that change how we understand other things like stars and black holes forming? The big challenge is figuring out how to make all the different theories about the universe's age fit together. The current theory, which says the universe is around 13.8 billion years old, has a lot of evidence behind it. But this new study is making us ask if that theory is missing something. One of the most interesting things about this is the tired light theory. If the red shift is because light loses energy as it travels, that could change how we understand light. It could open up new possibilities in space science and could change how we study distant objects. The idea that the cosmological constant might change over time is a big deal, too. It messes with the belief that dark energy stays the same throughout the universe's history. This could give us a better handle on dark energy and why the universe is speeding up. As scientists keep looking at this stuff, it's pretty clear that we're about to change how we see the universe. Whether this new model becomes the new normal is anybody's guess, but it's definitely getting people talking. It's a reminder that science is always changing. What we know now might not be what we know tomorrow, especially when there's new information that makes us question things. If the universe is way older than we thought, maybe 26.7 billion years old, we might need to rethink a lot of things. The timeline for when stars formed, how cosmic inflation works, what dark energy is, and how black holes form might all need to be reevaluated. It could also mean that some of the galaxies we're seeing with the James Webb Space Telescope aren't weird outliers. They might just fit into a longer timeline that allowed them to get bigger and more complex. This would help explain why some early galaxies seem so mature. But there are still a ton of unanswered questions. Can the tired light theory really work with everything else we know? How would a changing cosmological constant mess with quantum field theories? And what would it mean for us if the universe was way older? As technology gets better and we get more data, we'll be able to test these ideas. Over the next few years, there will probably be a lot of new discoveries and debates that will either support or challenge this new way of thinking. Until then, it's an exciting time in space science, where we're being asked to rethink everything. Whether we end up completely changing our model of the universe or just tweaking it a bit, one thing's for sure, the universe still has a lot of secrets, and we're just starting to figure them out. If we could nail down the universe's growth rate, we could figure out what the universe is made of like normal stuff, dark matter, radiation, neutrinos, dark energy, all that jazz. Plus, we could trace the universe all the way back to the Big Bang when it was super hot, packed tight, and tiny. The time it takes to get back to that point tells us how old the universe is. But get this. A study that came out on July 7th in the monthly notices of the Royal Astronomical Society is shaking things up. It says those old age estimates might be way off. This new study is tackling the problem of the first galaxies, which have been bugging scientists for ages. Turns out, some galaxies we thought formed super soon after the Big Bang might be way older than we thought. The James Webb Space Telescope saw that some galaxies, like this one called Methuselah, are so big and developed that they should have taken billions of years to get that way. That's weird because we thought these galaxies formed only a few 100 million years after the Big Bang. One professor at the University of Ottawa thinks these weird observations could mean the universe is way older than we thought. His study has a new idea that stretches out the timeline for galaxies to form by billions of years. He thinks the universe could be 26.7 billion years old, double what we thought. This new idea uses Fritz Zwicky's tired light theory. It says that light from far-off galaxies looks redder because it loses energy as it travels across space. So, light gets tired over long distances. That's different from the main idea, which says the redshift is because galaxies are moving away from us as the universe grows. The tired light theory has caused a lot of drama in the science world. Scientists are arguing about whether light losing energy over that distance would cause it to look redder and also dimmer. People say that if that were true, faraway objects would look way dimmer than they do. Plus, Zwicky's idea, which came out in the mid-20th century, didn't fit with the cosmic microwave background radiation. That radiation is everywhere and is like the leftover energy from the Big Bang. It was strong evidence for the expanding universe idea. Even though Zwicky's theory didn't seem to work with those observations at first, someone came up with a new angle. Now, the tired light theory can hang out with the expanding universe model. This new take says the redshift thing is a mix of both the universe growing and light losing energy as it travels. This not only brings back the tired light theory but also uses the idea of blocking constants of Paul Dirac. These constants are physical and control how particles interact. The theory is that they may have changed over time. Using this change of constants, the proposed new model stretches the timeline for the first galaxies that the James Webb Space Telescope saw. Rather than forming a few 100 million years after the Big Bang, these galaxies could have formed over several billion years, offering a better explanation for their size and mass. This model messes with the classic idea of the cosmological constant thought responsible for the dark energy. Instead, the model shows an updated version of the constant that takes into account the possible change of blocking constants over time. This change in the cosmological model could answer the problem of the small size of galaxies seen in the early universe, which gives an easier and more exact picture of space's evolution. So, what do you think? Have we been wrong this whole time? Drop your thoughts in the comments. If you liked the video, smash that like button and subscribe so you don't miss out on more stuff like this. Thanks for watching, and I'll catch you in the next one. This study isn't just big news, it could totally change how we think about the early universe and how it changed. If this new model is right, it could rewrite our understanding of everything from how galaxies form to the structure of spacetime itself. This could question assumptions that we've held for decades about the timeline of the universe. Scientists have thought the first galaxies formed pretty soon after the Big Bang, like within a few 100 million years. But the new evidence from the James Webb Space Telescope is forcing us to rethink this timeline. The thought that galaxies like Methuselah could have formed way earlier suggests we may need to relook at what the Big Bang was. Could the universe be older than we thought? And if so, what all would be changed in our understanding of other events like star and black hole formation? At the core of this is matching up the ideas that try to describe the age of the universe. We have lots of evidence for the current theory, which puts the age around 13.8 billion years, which includes the cosmic microwave background radiation and the observed redshift of distant galaxies. Most scientists accept the current model because of the observations. But this new study suggests this model could be not complete. One of the coolest aspects of this new research is the idea role of the tired light theory. If the redshift observed in distant galaxies is not only the expansion of the universe but also the losing of energy as light travels, it could offer a new meaning to light as energy in the cosmos. Although controversial, this theory could lead to new ways to understand distant objects in space. Also, of importance is the modification to the cosmological constant by suggesting that this constant may evolve over time. The new model goes away from the long belief that dark energy remains constant in the history of the universe. This idea could lead to a great understanding of dark energy and also its role in the accelerated expansion. As well, it could provide answers to galaxy formations, especially of unusually small sizes observed in galaxies from the early universe. As the science world continues to digest the findings, it is for sure a change in our understanding of the cosmos. This new model is not known to many if it will gain acceptance. The important fact is that it has started the conversation about age, structure, and evolution of the universe. This shows new proof is not immune to being challenged. Science grows with skepticism and revision, especially when there is data that questions old existing models. If the universe is much older than the believed 26.7 billion years, it would make the cosmology concepts re-examined, such as timeline of star formation, dark energy, behavior of cosmic inflation, and black holes might need to be revisited. As well, the most distant galaxies observed by the James Webb Space Telescope are not outliers, but the timeline allows more time for complexity, structure, and mass. If this is true, it would help resolve the maturity of the galaxies and shows the story for the universe's years of formation. Still, more questions are present. Can everything be aligned with all observations such as the cosmic microwave background and gravitational lensing with the tired light theory? How can an evolving cosmological constant interact with quantum field theories? The most suggestive of all these, what would a vastly older universe mean for us in it? We are better prepared to test new ideas as technology makes advances and the James Webb Space Telescope delivers these insights. In the next few years, here will be breakthroughs, peer reviews, and debates that reinforce or challenge this emerging paradigm.